Our Earth is called the Blue Planet, as more than 70% of the Earth's surface is water-covered and holds about 97% of all Earth's water. But even today, the unexplored oceans hold mysteries more compelling, environments more challenging, and life forms more bizarre than anything the known cosmic space has to offer. Our knowledge of the ocean is limited, especially considering the fact that more people have gone into space on various missions, while only 3 people have descended to the deepest part of the ocean, the Mariana Trench in the Pacific Ocean. Taking up this challenge of exploring and sustainably harvesting the vast resources of oceans, the Department of Ocean Development, now the Ministry of Earth Sciences, Government of India, established National Institute of Ocean Technology (NIOT) in November 1993 at Chennai, with a mandate to design, develop, demonstrate and utilize ocean technologies for the benefit of the country.
National Institute of Ocean Technology is the technical arm of Ministry of Earth Sciences and the only civilian institute in the country working in the area of ocean technology. For the past 2 decades, we have been working in this area relentlessly, and the success of many projects are well known to the country. We also have done lot of activity in the area of ocean energy, which is a renewable one, and also in desalination.
Water is such a precious and scarce resource in the islands of Lakshadweep, and NIOT's low-temperature thermal desalination-based technology plants developed and established at Kavaratti, Minikoi and Agatti. Presently, similar LTTD plants in another 6 islands of Union Territory of Lakshadweep, which includes Amini, Androth, Chetlat, Kadamat, Kalpeni and Kiltan Islands, is underway. The plants are technologically user-friendly and is being operated by the local people. Further, the Institute has largely contributed to the well-being of the islanders, as the availability of clean drinking water has substantially reduced the occurrence of waterborne diseases in these areas. In a bid to replicate this success story in the mainland, a 1 MLD LTTE plant set up off the Chennai coast in a floating barge was tested successfully. Adopting the concept of reduce, recycle and reuse of the Government of India, NIOT has developed a technology for desalination using the condenser reject water available in thermal power plants at the North Chennai Thermal Power Station NCTPS, and the other in Tuticorin Thermal Power Station is underway. The Institute strives to achieve desalination using ocean thermal energy to make economically affordable water of good quality. A priority project has been proposed at Kavaratti Island in Lakshadweep using ocean thermal energy conversion (OTEC). For hands-on understanding of the ocean thermal energy conversion cycle, a laboratory scale of OTEC plant has been set up at the Chennai campus with a 2 kilowatt power module combined with desalination. Through the continuous efforts of the Institute, India has now become the member of International Energy Agency's Ocean Energy Systems (IEA-OES), with NIOT being the designated agency. The Institute focuses on harnessing the ocean renewable energy in the form of waves, currents and temperature gradient. The floating wave-powered device called the Backward Bent Ducted Buoy (BBDB), based on the principle of oscillating water column, successfully generated power during the tests at the open sea. The wave-powered navigational buoy, also based on the principle of oscillating water column, has been fabricated and successfully tested near Kamarajar Port at Chennai. For harnessing electrical energy from the ocean currents, various straight and helical blade turbines were fabricated and tested. The straight-bladed turbine was then tested at South Andaman on a specially designed floating platform and towed for 48 kilometers. This successful trial, when the turbine generated 300 watts of electricity, more than expected output, paved the way for scaling up of 1 kilowatt turbine for off-grid units at Andaman. The Institute has taken up initiatives in development, fabrication and installation of systems in offshore wind sector using LIDAR-based data collection platforms. A platform was successfully installed at Gulf of Khambat for Ministry of New and Renewable Energy National Institute of Wind Energy MNRE, which is the first of its kind in Indian waters. An initiative to extract biofuel from algae has been successful. Biodiesel was produced by base-catalyzed trans-esterification reaction from the biolipids. Test run of biodiesel B10 powered vehicle from Nellore to Chennai was completed successfully. Estimates show that the methane stored in the form of gas hydrates, a non-renewable energy source, is in the order of approximately 950 trillion cubic meters within the Indian Exclusive Economic Zone. For the ground truth validation of gas hydrate occurrences and to quantify the resource in the Indian waters, NIOT acquired the technology for an underwater wireline autonomous coring system ACS. The system has been qualified for 3,000 meter operations and drilled up to 40 meters below the seafloor at 850 meter water depth. Further trials and coring at KG Basin site are on the anvil.
Some of the societal activities which we take up are ocean observations, wherein we put up lot of data buoys in the ocean which measure the parameters and send it to Indian Meteorological Department for effective weather prediction. In the area of coastal protection, we take up sustainable protection measures like in the case of Pondicherry, Kadalur Periyakupam, Visakhapatnam, etc. We have got a large group to develop indigenous technology. Many technologies which we have developed at the institute have been transferred to the industry successfully, and this gives the Indian industry a name through Make in India program.
In order to augment our understanding of the ocean processes and their implications of the climate and natural hazards, the Institute has set up a real-time monitoring system for obtaining reliable data relating to different oceanographic and meteorological parameters such as waves, currents, temperature and salinity. Through a network of data buoys, which includes 19 moored buoys in the monitoring of the Indian seas and 1 buoy at the Arctic seas. Under the Indo-US collaboration, the Institute supports RAMA buoys network of 25 moorings in Indian Ocean under the Global Ocean Observation Program. The Institute maintains a fleet of buoys, including the moored Met-Ocean buoys for measuring meteorological and surface parameters, the Omni buoys to measure solar radiation, rainfall and subsurface parameters up to 500 meters below sea surface. The Institute's Tsunami buoys plays a crucial role in warning the Indian coast against tsunamis by providing real-time data on ocean parameters. The data captured by the tsunami buoys are transmitted through satellite to the Automatic Data Reception Center at the campus, and finally is disseminated to INCOIS for operational purposes. The Institute's observational network is further strengthened by the high-frequency radars established along Andaman and Nicobar Islands, Andhra Pradesh, Gujarat, Odisha and Tamil Nadu for continuous observation of large-scale oceanographic measurements like coastal currents and waves. The Institute's aquatic glider Bharati, equipped with GPS and conductivity temperature profiler, is capable of diving to 950-meter water depth and transmits data acquired from such depths. INDARC, the first ever Indian underwater moored observatory in polar waters to study climate change, was established by NIOT and NCAOR at Kongsfjorden, 1,000 kilometers away from the North Pole Basin. Also, a new ambient noise measurement system along with INDARC mooring was successfully deployed and is now operational in Arctic waters to study the ice dynamics, bioacoustics and sound propagation in polar regions. Further, to enhance the ocean observational network, the Institute has successfully developed AUPDs, the autonomous underwater profiling drifters that are fitted with CTD sensors and capable of profiling up to 2,000 meters water depth. The periodic profiles of the temperature and salinity would enable better understanding of the ocean circulation, enhance climate predictability, and validation of satellite data. The drifting buoys Pradyu with INSAT Communications has been developed and tested successfully at sea to collect and process the meteorological and oceanographic parameters. The other indigenous innovations developed in-house include the Aquabot, Variable Buoyancy Aquatic Glider, Robo-Coastal Observer, and 6 variants of Data Acquisition System DAS for data buoys. Robo-Coastal Observer is a buoyant ring or life jacket deployable from shore that could be operated remotely using RF-GPRS satellite telemetry. In addition, it could be used for rescue of a drowning person in any water body. Development of a portable, high-power wideband acoustic transmitter for sub-bottom profiling and miniaturized hydrophone arrays for underwater applications enhances the in-house technological capabilities. The Institute has successfully transferred the technology to the industry of many of these systems developed in-house. The Institute has accomplished more than 200 projects along the Indian coast to cater to coastal infrastructure development with real-time observation, numerical modeling and engineering solutions. The Institute plays a major role in the Kalpasar project, one of the major initiatives by the Government of Gujarat, which includes field investigation activities at Gulf of Khambat, such as geotechnical and geophysical surveys, hydrodynamic wave sediment transport, storm surge model and reservoir model studies, and optimization of sluice gates for saline water discharge. Further, several port infrastructure development projects and port layout studies in various environmental conditions were successfully executed at Andhra's Krishnapatnam and Gujarat's Pipavav port. The Institute is extremely proud and highly satisfied of having contributed to the society by restoring the lost beach at tourism-rich Puducherry. Puducherry has lost its beaches to coastal erosion, and the entire coast was protected with sea walls. The Institute initiated the construction of a submerged, triangular, wedge-shaped reef on the north, coupled with an offshore reef on the south, spaced at a distance of 1.5 kilometers from each other. The structures, along with beach nourishment, led to the formation of beach of width of about 60 meters near the new pier. The new beach attracted a lot of happy beachgoers. Shoreline mitigation activities have also been carried out at Ramakrishna Beach, Visakhapatnam, and Kadalur Periyakuppam off Chennai coast, using submerged dike, which helps dissipate the energy of larger waves without completely blocking the waves. The technical criteria atlas developed in-house is the first of its kind and is a ready reference for engineering design with emphasis on bays and inlets. To help coastal engineers, a digital wave atlas is also being published with a 50-year return period statistics. In addition, a real-time oceanographic data portal, port monitoring system, wave atlas and storm surge web portal Disseminate is also being published for the benefit of various stakeholders. The Institute designed and fabricated and demonstrated open sea cages for culture of finfishes and successfully implemented the same at North Bay, Port Blair, Olaikuda, Tamil Nadu and Kottachatram and Tuplipalam in Nellore, Andhra Pradesh. The Institute shares the nation's vision on blue economy and strives to develop technologies that utilize the vast resources of the oceans to address the problems of resource scarcity and enhance the livelihood of the coastal communities. In a bid to improve the fish catch, 28 fish aggregating devices, FADs, were deployed around Lakshadweep Islands, and 750 artificial reef structures were designed, fabricated and deployed along Odisha coast. Post-deployment studies revealed that there was a substantial increase in fish capture, decrease in trawl net operation and more protection to turtles' nesting grounds.
Coming to the niche areas, we work in the deep sea technology. We have a mandate set by the International Seabed Authority wherein we have to develop the technology to take out manganese nodules from deep sea from a depth of 6,000 meters. We are in the process of setting up an underwater crawler which will move on the seabed and mine these manganese nodules which contain cobalt, nickel, etc. which are of strategic importance. We have done lot of work in deep sea. We have developed a remotely operable vehicle which also can go to 6,000 meters and also soil tester which can measure the soil property in situ at a depth of 6,000 meters. As part of the deep ocean mission, we are having a major project to develop a manned submersible capable of taking 3 human beings up to a depth of 6 kilometers down to explore the ocean at that particular depth.
The major non-living resource that the oceans offer are polymetallic nodules, cobalt-rich manganese crust and hydrothermal deposits. As a pioneer investor, India has been allotted 75,000 square kilometer area in the Central Indian Ocean Basin CIOB by the International Seabed Authority towards exploration and technology development for polymetallic nodule mining at 6,000 meters water depth. Surveys conducted estimate the resource potential of polymetallic nodules in the area as 380 million tons. As a milestone effort and part of the technology development for the deep sea exploration, a remotely operable in situ soil tester was developed for 6,000 meter operations. Soil property measurements have been carried out at 5,462 meter water depth in the Central Indian Ocean Basin. The augmentation of the deep sea crawler with collector crusher has been developed and tested at the sea by pumping artificial nodules laid on the seabed. Efforts are on to develop crawler-based mining machine for 6,000 meter depth. As part of the deep sea exploration program, the 6,000 meter depth rated deep water remotely operated vehicle ROV was designed, developed and successfully demonstrated at the Central Indian Ocean Basin at 5,289 meters for mineral exploration. The system was demonstrated for hydrothermal sulfides exploration at the Central Indian Ridge in the Indian Ocean near the Rodriguez Triple Junction at 2,800 meters depth. Further, the scientific exploration of gas hydrate was conducted with the ROV at a depth of 1,037 meters and 1,019 meters in Krishna Godavari Basin in Bay of Bengal. NIOT scientists deployed the indigenously developed Polar ROV during the recent scientific expedition to Antarctica. The vehicle was deployed at the New Indian Barrier Ice Shelf region up to 62 meters water depth. The Polar ROV was further used for coral reef expedition in the Andaman and Nicobar Islands of India. A buried object detection sonar system capable of finding targets buried in the seabed for civilian and various other applications has been indigenously developed in-house. A manned research submersible can combine the advantages of an ROV and remotely operated autonomous vehicles. Hence, the Institute is in the process of developing a manned submersible with a depth rating of 6,000 meters to aid direct human intervention. A mock-up sphere treated as an acclimatization chamber has been developed for testing various parameters.
In the area of underwater communications, acoustics is the only medium for communication. We are developing various instruments for underwater communications as well as measuring the various parameters of the ocean in the deep sea.
The Institute's current research focus is on ocean ambient noise measurement passive acoustic systems for oceanographic and surveillance applications, sound propagation and ambient noise modeling, acoustic communication, seabed characterization and bioacoustics. Ambient noise is the prevailing sustained background sound in the ocean, wind wave activity, rainfall, shipping and biological species. A totally indigenous, automated ambient noise measurement system with a vertical linear array of 21 omnidirectional hydrophones and a real-time communication has been developed for time series measurements, ambient noise stations at Goa, Cochin, Chennai, Visakhapatnam, Kakinada and Kadalur have been established.
Our institute has got excellent collaboration with similar international laboratories like JAMSTEC in Japan, IFREMER in France, Woodsole Oceanographic Institute in the USA. We also have collaborations with many of these international labs.
A hyperbaric chamber used to simulate the pressure in the deep sea environment is established to test components with external pressure up to 900 bar, which is approximately equal to 9,000 meter water depth. A soft soil seabed simulating the seabed conditions has been developed at the Mining Department, Anna University, for undertaking experimental studies of the nodules pickup and collecting systems and related soil-machine interaction studies. A state-of-the-art acoustic test facility credited with international standards caters to the testing and calibration needs of the country. The underwater electronic support facility includes helium leak detector, shock and vibration test facility, corrosion chamber and environmental chamber. A sophisticated calibration facility has been established as recommended by World Meteorological Organization WMO for Regional Instrument Center RIC laboratories to calibrate various sensors in the ocean observation systems. The robust research vessels, the floating labs, contribute majorly in research, exploration and technology demonstration efforts. Ocean research vessel Sagar Nidhi is a state-of-the-art ice-class research vessel of the subcontinent. Sagar Nidhi sailed successfully through the 66 degrees south latitude, facing 11 storms and 73 nautical miles per hour wind speed to reach Antarctica waters. Buoy tender vessel Sagar Manjusha carries out the deployment and recovery of ocean observation systems and also caters to the requirements of other institutes of the ministry. Coastal Research Vessel is used for the implementation of programs for MOES-funded projects, universities and research institutes. The The Institute's new coastal research vessels will add impetus to the coastal research activity. A novel deep-sea microbial culture facility 350 bar pressure system has been customized and installed. As a part of marine algal biotechnology activity, 3 types of mass culture systems, the tubular photobioreactor, bubble column photobioreactor, and solar-powered operated raceway culture system for mass culturing has been developed and tested. Further, a DC-powered electroflocculation system was developed and patented for harvesting microalgae with 98% efficiency. Pilot-scale production of nutraceuticals in open raceway ponds is undertaken at the Institute's Nellore seafront facility. In the marine realm, the bio-invasions have been attributed to ballast water used to stabilize ocean-going vessels. As part of Niti Aayog project, establishment of a ballast water treatment technologies test facility is in progress on the east coast of India at Pamanji village of Nellore district in Andhra Pradesh. An upgraded state-of-the-art field laboratory facility, Atal Center for Ocean Science and Technology for Islands, provides services by developing Island Resource Information System and EIA activities. Sagar Sangamam Conference Center at the Chennai campus is a state-of-the-art conference center hall to conduct meetings, scientific seminar sessions and conferences.
Friends, I am very happy to meet all of you to celebrate the Technology Day.
The scientists and the technical community benefits largely from the in-house library. NIOT's eco-friendly green campus is nurtured round the clock with a great degree of social responsibility.
Oceans also will become a strategic issue for the country, like what we had in space as well as atomic energy 30 years back. And because of strategic importance for the oceans, no other country will share the technology with us. We have to develop ocean technology ourselves. This indigenous technology development should be made. So NIOT will play a pivotal role to make this kind of development for the country. As far as deep ocean is concerned, we know very little about deep ocean. For example, only 5% of the deep ocean has been already explored. 95% of the deep ocean is unexplored. So the deep ocean mission will definitely give you an opportunity for exploring further insights to the deep ocean, to understand the complexity of the deep ocean and also to harness the resources from the deep oceans.
NIOT scientists have won accolades in the area of ocean technology and have many patents and high-impact journal publications to their credit and hold a niche place for themselves in the field of ocean technology. Today, NIOT, fully aware of the long road ahead, recommits itself to identify new challenges and future requirements in the field of ocean technology so as to optimally use the ocean and its vast resources to support the nation in achieving self-sufficiency in food, water and energy.